This learning target involves inscribed angles. What is an inscribed angle? An inscribed angle is the angle whose vertex is on the circle, so like B, and the sides are chords. Okay, so those two are my chords, and so CBD is an inscribed angle. Okay? All right. If we draw another segment or chord, no segment, there, what kind of triangle then is ABC? Yeah, it's going to be isosceles. Why is this side equal to that side? Because of the radius, absolutely. So that makes an isosceles triangle. Okay, so that means this angle has to be congruent to that angle. Would you agree with that? Awesome. Okay, if ABC, the measure of ABC, so this one is x degrees, we want to find what CAD, or CAD, sorry. Okay, so if we're looking for, we'll call this X, or we're looking for this angle here, how can we set that up? Why is it X plus X? I agree with that. But how do you know, or why is this angle equal to this angle and this angle? Ooh, you're on the right track, but not quite. It was a theorem from about then. What kind of angle does this make? If we're looking at this triangle here, beautiful, exterior. This one's an exterior angle. Okay? And there is a theorem about an exterior angle. It equals something. Alternate, it's not alternate. Well, let's think about it. If this is my exterior angle, okay, and what are these two angles? What are they called? Interior, and there was another word. Nah, they were the remote interior. Because these two have to equal this, because this angle plus this equal 180, and all three of those would equal 180. So therefore, those two have to equal that one. So if I have the measure of angle CAD equaling 2x, that means that my arc is going to be equal to 2x. Okay, do you agree with that? So if my arc is 2x, and the measure of my inscribed angle is x, what does that tell you? If the arc is 2x and the angle's x, what's that tell you? The arc is 2 times the angle. Perfect. or the angle is 1/2 the arc. Beautiful. Okay, so that gives us to our theorem. The inscribed angle is always half the measure of its, half the measure of the arc. And if you have two inscribed angles that intercept the same arc, then they're always congruent. That makes sense. Okay, so find each of the measures in BCD if DB equals 68. All right, so let's start with, if we know this angle is 68, what is or this arc 68, what's this angle going to be? Half DA, half, so it's going to be 34. Awesome. What's the measure of this arc here? How can we figure that out? Well, what kind of circle is it? Oops, I can bring that up a little. What kind of circle is that? It's a semicircle. So what's it arc equal to? 180. Right, so a semi is 180. So if I subtract 68, then this arc's going to be, let's see, that would be 112. Okay, so since this is the angle that intercepts that arc, what's the measure of B going to be? What's half of 112?
That would be 60.
Would be 56. All right. Now, let's find the measure of D. Since D intercepts this arc right here, what's the measure of that arc? 180, because it's a semicircle. So what's D going to be? 90. Because 180 divided by 2 is going to give you 90. Good? Make sense so far? Okay. Alrighty, if an inscribed angle subtends a semicircle, what's subtends mean? Kinda. It's basically so. If it, what's the right word? Because it's going to create a right angle. Okay, so here's my angle. Okay, when it is not anywhere on the semicircle, where it basically is in both semicircles. That's what the subtend means. It's kind of in both of the semicircles. It overlaps each other. Okay? It's going to make it a right angle. Okay? So if I have DB equaling 154 and CB equaling 72, okay, so here's my inscribed angle, and it has this arc here. What's my angle measure for C going to be? $154 divided by 2 gives me 77. Okay. All right, CB. This is marked. Let's make this CD because it's marked differently. So CD is 72. That means I'm looking at angle B. And since 72 divided by 2 gives me 36. So how can I find what angle D is going to be? 180 or 180 minus 77 and 36, and that gives me 67. Okay, good. All right. I have my inscribed angle. Okay? It divides it in half. So that makes this a what? That makes that a semicircle. So that's going to be 180. So what is N going to be? 90. So I can say 3W minus 9 equals 90. If I add 9 to each side, 3W equals 99. And so W equals 33. Good so far? Does that make sense to you guys? And W's 33. No, and the angle, that's going to be 90 because it's half of 180. Does that make sense? All right, go to the last example. Okay, let's find each of the angles of our quadrilateral. Okay, if this arc right here is 208, okay, and this one's 46, and that one's 64, 360, that's going to give this 42. Do you agree with that? Okay, so if I'm looking at you, there's my inscribed angle. And so my arc is going to be 42 plus 46, which gives me 88. And if I divide 88 by 2, that gives me 44 degrees. Do you agree with that one? All right, let's find R. Here's my inscribed arc. So that means my arc this time is going to be 64 plus 42, because that's my arc. And when I divide that by 2, I get 53. Good so far? Does this make sense, what I'm doing? All right, so let's find S. Here's my arc. or I mean, here's my inscribed angle. That means my arc is this whole thing, which is 64 plus 208. And when I divide that by 2, I get 136. I'm sorry? Here? 136. 53? All right. Now, to find t, I can use my inscribed angle. What else could I do?
Add up all of the angles and subtract 28
I can do that too. I could either look at my arc, or I can, since it's four-sided, I'm going to have 360, and I could subtract all of them, of the other angles, and get my angle measure of 127. Either way works. Okay, so if I add T and R up, they're going to equal 180. U and S, because they're opposite each other, they equal 180. Which brings us to another theorem, that the opposite angles are always supplementary. What's that mean? So, what's supplementary? Equal 180. So that means that in this, since they're opposite each other, 4x plus 5x minus 3 equals 180. If I add 3 to both sides, and so x is going to be 20.3 repeating. Good? Questions about that? Does that make sense?